class. Today we're going to do Chapter 9, Measurement, and look at Chapter 9.2, Measuring Area and Volume. Our objectives today are to use square units to measure area, use dimensional analysis to change units for area, use cubic units to measure volume, and use English and metric units to measure capacity. So, let's look at measuring area. Let's start with something simple, the square unit. A square, each of whose sides is 1 unit in length. Okay, so 1 square unit would just be a 1 unit by 1 unit square, as we can see on the left here. 1 square inch would be 1 inch by 1 inch, which gives us a square inch. Okay, so you get 1 inch on one side of the square, 1 inch on the other side of the square. Remember, area is length times width. 1 times 1 is 1. So this is 1 square inch. 1 square centimeter will look like this on the right. So 1 centimeter length, 1 centimeter width. 1 times 1 is 1, giving you 1 centimeter squared for a 1 square centimeter area. Now let's measure area. What is the area of this region using the square units? Okay, remember each one of those square units is 1 square unit. All we have to do to find the area of this region is to count the number of squares within this region. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. We count 12 square units within this region. Therefore, the area is 12 square units. What we could also instead do is say, okay, this is a 1, 2, 3 unit by 1, 2, 3, 4 unit region. 3 times 4 is 12. Okay. So let's look at this. 1 square foot. Okay, 1 square foot can be represented in several ways. The first way we see here is a 1 foot by 1 foot square. Okay, so it's 1 foot on your length, 1 foot on your width, and that is 1 square foot. It could also be broken down into 12 inches and 12 inches. Okay, and if you notice here, each one of these little squares represents a square inch. So a 12 inch by 12 inch square is technically still a 1 foot square, right? Because 12 inches is same thing as 1 foot. Okay, so here your area is 1 foot times 1 foot gives you 1 foot squared with the initial square. Here the area is 12 inch times 12 inch, which gives you 144 inches squared. And because the units have the same area here, this square is the same as this square because 1 foot is the same as 12 inches. It means that 1 foot squared is the same thing as 144 inches squared. Take that in for a minute. So 1 foot squared isn't the same thing as 12 inches squared. 1 foot squared is the same thing as 144 inches squared. Because we actually have to square that 12 on the inside because here we have the double multiplication by it right there. Works the same thing with a yard. 1 yard by 1 yard gives me a 1 yard squared. But I could break this down into feet instead. It'll be the exact same square if I do 3 feet by 3 feet. Because 3 feet equals a yard, right? So this is also 1 square yard right here, just broken down into feet. And if we look at this, 1 yard times 1 yard is 1 yard squared. 3 feet times 3 feet is 9 feet squared. So it has to be true that 1 yard squared is the same thing as 3 feet squared. So let's look at some of these conversions here. 1 square foot is the same thing as 144 square inches. 1 square yard is the same thing as 9 square feet. 1 acre is the same thing as 43,560 feet squared, or 4,840 yards squared. 1 square mile is the same thing as 640 acres. All right, let's look at example 2, using square units to compute population density. After Alaska, Wyoming is the least densely populated state. The population of Wyoming is 578,759, and its area is 97,814 square miles. What is Wyoming's population density? All right, now in order to compute this population density, what we're doing is dividing Wyoming's population by its area. So the population density here equals the population divided by the area. Okay, the population is the number of people, which is 578,759 people. The area here is the 97,814 square miles. Let's do this division using the calculator and rounding to the nearest tenth. Once we do that, we see that we should obtain a population density of about 5.9 people per square mile of area. So that is how we find population density. Number of people over number, or our area in this case. In this case, our area, we use square miles. All right, and of course, even with area, we can still look at the unit conversions for English and metric equivalents. So 1 square inch is going to be the same thing as 6.5 square centimeters. 1 square foot is going to be the same as 0.09 square meters. 1 square yard is going to be 0.8 square meters. 1 square mile is going to be 2.6 square kilometers. And 1 acre is approximately the same thing as 0.4 hectare. So abbreviated HA. Hectare, I think is how they say that. Sorry, hectare. Okay, hectare. Growing up, I always thought hectare and hectare were the same thing, and it was a little confusing. They probably are. I was probably just saying it wrong the whole time. So hectare. Interesting. Let's look at example 4. Using dimensional analysis on units of area. A property in Italy is advertised at $545,000 for 6.8 hectares. Now we want to find the area of the property in acres. So the solution to convert 6.8 hectares to area, we use a unit fraction with acres in the numerator, hectares in the denominator. Okay, so basically what we're going to do here, we're going to find the area of this property in acres. We're going to start with the 6.8 HA. Okay, now the key here is they gave you some information that you did not need. We didn't need to know how much the property cost, because all we're doing is converting the acreage here. Okay, so here I'm going from 6.8 and I'm trying to get it to acres. So I'm going to start with the 6.8 HA, and then I want that unit conversion that we have. Now if we go back here and look at our unit conversion here for acre and hectare, we see that 1 acre equals 0.4 hectares. I'm going to struggle pronouncing that for the rest of my life. Anyways, I set this up with the acre on top and the hectare on the bottom here because I want the HAs to cancel. Okay, that's the only way that's going to happen. If you put the HA on top, it's not going to cancel. You're going to wind up with HA squared over acres, which is not going to make any sense. Okay, we want it to cancel and leave it just with acres. So essentially what we're doing is 6.8 divided by 0.4. So 6.8 divided by 0.4 equals 17 acres. So we can convert 6.8 hectares into 17 acres. How about that? Now, part B does use this actual 545,000. Okay, part A did. So part B says, what is the price per acre? Now, if we've got 17 acres in total, and it cost overall $545,000, and we want the price per acre, then essentially what we're going to do is take the amount that it costs, the $545,000, and divide it by the number of acres we have, and that will render us with the price per acre. So I'm doing 545,000 divided by 17 acres, and that's going to give us $32,059 per acre. Quite expensive. All right, let's move on. Let's look at measuring volume. 3 dimensions, ladies and gentlemen. The volume refers to the amount of space occupied by a three-dimensional figure. In order to measure this space, we begin by selecting a cubic unit. 1 cubic foot, so foot raised to the third power, equals 12 to the third power, which equals 1,728 cubic inches. You're like, okay, why do we choose 12 here? We are trying to convert cubic feet into cubic inches. Okay. Now, we know that there's 12 inches in 1 foot. We know that unit conversion. That's why we use the 12. So essentially what you're doing here is you are taking that 12 from that conversion, and not only, if you're wanting to cube the inches part, you got to cube the number part that goes with it, and that's that 12 right there. So 12 cubed is 1,728. So that's how we get 1 cubic foot is 1,728 cubic inches. Now if we want 1 cubic yard and convert that to feet, remember that there's 3 feet in every yard, okay? Which means if I'm converting a cubic yard into cubic feet, essentially what I'm doing here in my intermediate step is taking 3 to the third, because there's 3 feet in 1 yard. 3 to the third is 27. That's how I get 27 cubic feet. Now let's look at measuring volume. What is the volume of this solid? Okay, so a cubic unit is just a square shaped cube, right? So each side here in the cube, you got your squares on every side of it, and each one of those squares is equivalent. So each one of these sides on each one of these squares is the same unit of measure here, or is the same measure itself. So that's what gives you the cubic unit. So you basically start from a single line, you you go up to basically a 2-dimensional figure, and then you go up to a 3-dimensional figure here. So this is what we're looking at. We got a cubic unit here. Volume is length times width times height in these figures. But what we want to determine here is we see this figure and we can't see all the pieces of it. So mentally, some people are able to kind of break this down and say, okay, I'll count what I see and then I'll kind of figure out what I don't see. Okay, so here's what I can see and here's kind of what I can't see. So I can see this one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But then there's a few that you can't see, because you couldn't see this one, 15, 16, 17. You couldn't see the one on the bottom, that'd be 18, right? So you kind of have to visualize where it's at, because when you got a 3-dimensional figure on a 2-dimensional plane, which is your screen at this time, then it can be hard to visualize it. Another easier way to do it here is, like I said, our volume here is length times width times height. This is 2 by 3 by 3. So length, width, height. You can call this one L. You can call this one W. You can call this one H. 3 times 3 is 9 times 2 is 18. There are 18 cubic units. So you can count it. You can visualize it. You can multiply it. Whatever works easiest for you and your brain. Okay. Now, this links us to capacity. Okay, capacity is the amount of fluid a 3-dimensional object can hold. Now, our English units for capacity are cups, ounces, quarts, gallons, and we have the conversion for these here. So 1 cup is 8 ounces. 4 quarts is 1 gallon. 1 gallon is 128 ounces. 1 cup is 8 fluid ounces. Okay. Now, let's look at the volume in cubic units versus the capacity. Okay, 1 cubic yard has a capacity of about 200 gallons. 1 cubic foot has a capacity of about 7.48 gallons. 231 cubic inches is about 1 gallon. Okay, those might be new to you. Hopefully you know your conversions for your cups to ounces, ounces to quarts and gallons and all those, and you could even throw pints in there if you wanted to. Hopefully at least you're semi-familiar with those. Volume, maybe not so much, especially as it relates to capacity. But we kind of got a little list here, got a little chart going. Let's see what example 6 is going to ask us. Example 6 for volume and capacity in the English system says a swimming pool has a volume of 22,500 cubic feet. How many gallons of water does the pool hold? Okay, so we know it has a volume of 22,500 cubic feet. We're going for gallons here. Going for gallons. If I look back here at my chart here, I'm trying to go from feet, so foot, to gallons. That's going to be my conversion here. 1 cubic foot is about 7.48 gallons. So the unit fraction we're going to use is 7.48 gallons over 1 foot cubed. We're going to start out with our initial information from our problem, the 22,500 feet cubed. I'm going to set that up as its own fraction here. Ignore the slash outs. They're just inputted in the lecture a little early. So I'm going to start out with 22,500 feet to the third over 1. I want to cancel that out, which is why I put my unit conversion as 7.48 gallons over 1 foot to the third instead of 1 foot to the third over 7.48 gallons, because I want my feet here to cancel, and that's going to allow that to do so. All right, so now all I'm really looking at here is 22,500 times 7.48. That will render me the number of gallons that this volume of swimming pool here can hold. So we see by this conversion that it's going to hold approximately 168,300 gallons. So the pool holds approximately 168,300 gallons of water. It's a lot of water. That is a lot of water. All right, units of capacity in the metric system. So breaks down the same way. The same style symbols are on these as was on the meters. That's the one good thing about the metric system. It stays extremely consistent with the abbreviations. Okay, so you got your kiloliter, your hectoliter, your deciliter, your liter, your deciliter, your centiliter, and your milliliter. Okay, pretty simple, right? So kiloliter still means the same thing. Still means 1,000 liters. Hectoliter is 100 liters. Deciliter is 10 liters. A liter is just 1 liter, obviously. A deciliter is 0.1 liters. Centiliter is 0.01 liters. And a milliliter is 0.001 liters. Okay. Now, we also can look at this in volumetric capacities here. So, volume in cubic units versus our capacity for centimeters here. 1 centimeter cubed is the same thing as 1 milliliter. 1 decimeter cubed, which is 1,000 centimeters cubed, is 1 liter. Okay, and 1 meter cubed is the same thing as 1 kiloliter. So we got an interesting conversion there. All right, we've got our chart. We might refer back to it in just a second. It says an aquarium has a volume of 36,000 cubic centimeters. How many liters of water does the aquarium hold? Starting out here, let's just break down a problem real quick. 36,000 cubic centimeters. Okay, got 36,000 cubic centimeters. Trying to figure out how many liters of water it holds. If I go back to my chart here, starting out with cubic centimeters. Cubic centimeters. Okay, cubic centimeters. I see one there. Okay, but we're trying to get to liters. Okay, oof. This is only going to get us to milliliters. And our chart here says 1,000 centimeters cubed gives me 1 liter. We might use that conversion instead of the initial conversion. So we're going to use the conversion of 1,000 centimeters cubed to 1 liter. Let's do that. That'll be our unit fraction. So we're going to start out with our 36,000 centimeters cubed. We're going to put that over 1. We're going to use our unit fraction that we found from this chart back here. And we're going to do 1 liter over 1,000 centimeters cubed, because that is our unit fraction that we learned directly from the chart right here, because those are equivalent. So we can divide them, and it's essentially 1. That's going to allow us to cancel out these centimeters cubed here, which is very nice, because it's going to leave us with the liters that we want. So we're essentially just looking for 36,000 divided by 1,000, which gives us 36 liters. So 36,000 cubic centimeters is the same thing as 36 liters, and thus completes chapter 9.2. Now, you'll have quite a few different style examples in your homework or your assignment. So go on, give those a try, see how those work out for you. Let me know if you have any problems or issues. Take your time with them. I know these lectures can seem like they go by really, really fast, but it's intended for you to kind of stop the lecture and semi-work these problems on your own before sitting here and just watching me breeze through it. I've done problems like these my entire life, and this is my area of expertise, so I can make things seem really simple. So if you need to kind of sit there and work on it your own, and then hit pause and replay as you need to make sure you can see and understand exactly what's going on. If you don't, you might need to watch it again or reach out to me to see what's going on. But I will see y'all back here for chapter 9.3 on the next lecture. If you have any questions, comments, criticisms, reach out to me, and I will help you as best I can. I'll see you next time.